Hello everyone. Today we will look into solving quadratic equations by using the zero product property. When you multiply a number with 0, your result is 0. So we are going to use that knowledge, zero product property, to solve quadratic equations. If a product of binomials is equal to 0, then one or both factors must be equal to 0. Here are our steps for solving single variable trinomial quadratic equations. We will move all the terms to one side of the equation so that the other side is equal to 0. We will factor the polynomial, rewrite each factor equal to 0, and solve for the variable. Check your work by plugging your solution back into the original equation. Here is our first example. All of our terms are already on one side of the equation. So it's already equal to 0. So we can go to our second step, factor the polynomial. This would be an easy factoring method because leading coefficient is already 1. Since the leading coefficient is already 1, we can find factors of 15 that could add up to negative 8. Factors of 15 that can add up to negative 8 are negative 5 and negative 3. I can write my factors as a binomial x minus 5, x minus 3 equals 0. At this step, I'm going to rewrite each factor equal to 0, then solve for the variable. I will write x minus 5 equals 0, and I will write x minus 3 equals 0. Then to solve this, I will add 5 to each side. X is equal to 5. I'll add 3 to each side on the next one. X will be equal to 3. So we have our solutions. In this case, our solutions, x values are 5 and 3. Let's write them in increasing order. 3, 5. We can also do a check step by substituting both of the results, 3 and 5, back into the original equation. Then we substitute, we should have result of 0. I only showed one of the solutions in my check step. We should solve both of them. We should show both of the solution in our check step to make sure that both of them are correct solutions. Here is your U-try. Here's our next example. In this example, we do not have all of the variables on one side of the equal sign. So we're going to subtract x from each side, and we're going to carry all the x's to the left. This will give us 2x squared minus 7x equals negative 3. Let's add 3 to each side to finalize our problem. We will have only 0 left on the right side, so I can write 0 on the right side. On the left side, we are going to have 2x squared minus 7x plus 3. I did not add 7x to 3 because they are not like term. I left them in addition format. Now, after writing the equation equal to 0, we are going to factor the polynomial as our next step. This is going to be a longer way of factoring because leading coefficient is not 1. So I'm going to use the grouping method. I will multiply first number to last number. 2 times 3 is equal to 6. And then I will find factors of 6 that could add up to middle term, which is negative 7. Negative 6 and negative 1 are factors of negative 6 that could add up to the middle term. And we can split the middle term into two parts, where we would have 2x squared minus 6x minus 1x plus 3 equals 0. At this step, we are going to apply the grouping method. Let me copy everything to side. We are going to find the first group and the next group. In the first group, we will determine our greatest common factor, which is going to be 2x. On the next group, greatest common factor is going to be -1. We will factor out the negative because it is the leading coefficient. If I factor out 2x from the first group, we would have x minus 3. If I factor out the -1 from the next group, we will have x minus 3. Seeing matching binomials indicates that we are on the right track. We are going to factor out the common binomial one last time. In this case, x minus 3 is the common binomial. If I factored out the common binomial, we will have x minus 3 factored out and 2x left from the first one minus 1 left from the second one. According to zero product property, either the first group equal to 0 or the second multiplication factor equal to 0. And if we write x minus 3 equal to 0, then x must be equal to 3. If we write 2x minus 1 equals 0, then 2x will be equal to 1 and x will be equal to 1/2. So we have found two solutions. One is x is equal to 3, the other one is x is equal to 1/2. We can again do a check work by substituting each of them into the original equation, and it should give us a true result. Here is your U try. Here's my last example. In this example, we are dealing with a greatest common factor scenario. And if I look at the problem, I can recognize 2 is a common factor for every term. Also, x is a common factor for every term. So I'm going to factor out the greatest common factor, 2x from everyone first. If I factor out 2x, I should have x squared minus 4x minus 5 as our remaining part inside of the parenthesis. Now, the remaining part inside of the parenthesis is still a quadratic equation, and we'll have to check to see if that is factorable. And because leading coefficient is 1, we can try the easy method, and we can try to find factors of -5, which could add up to -4. Factors of -5 are -5 and +1 that add up to -4. So I can write out my factors as 2x, x minus 5, and x plus 1 equals 0. According to zero product property, if you have 0 times a number is equal to 0, or if we have 0 times 0 is equal to 0. In this case, we have 3 terms. Out of these 3 terms, any of the 3 or all of them could be equal to 0. So we can write 2x equals 0 to find one solution, and we can write x minus 5 equals 0 to find the next solution, and x plus 1 equals 0 to find the last solution. And from the first one, I will have x1, first x value as 0. From the second one, I'll have x2, the second solution is 5. From the last one, I'll have x3, the third x solution is going to be -1. So we have essentially found 1, 2, 3 answers for our solution to this problem. So I can write the x values as -1, 0, and 5. We can do a check step by substituting each of them into the original equation to confirm that they are satisfying this equation. Here is your U try. That's pretty much it. Make sure to bring your questions to the class.